Well, I just wanted to check out how monsoon is progressing and how accurately the IMD, that is the Indian Meteorological Department, is predicting the day-to-day rainfall and temperature, humidity, etc. values. All I wanted was to look at comparison graphs and maps of observations and forecasts. That is, observations and forecasts put together in one page so that I can decide how much to believe in the weather predictions. But such comparison graphs are not available anywhere. We need plots like these Karnataka maps. On the left, we have a forecast made for the 24-hour period between 12th July 8:30 am to 13th July 8:30 am. And on the right, we have the observed rainfall for the same period. So the left image is the forecast and the right image is the observed value. These maps are, however, not from IMD. They are from the daily reports of KSNDMC, that is the Karnataka State Natural Disaster Monitoring Center. And these images are from their daily reports on 2 different days. They don't give any comparison plots in their reports. But one good thing about KSNDMC is that it maintains an archive of the reports. It has only 3 to 4 days missing data since June 1st. And they have a great real-time data dashboard for Bengaluru city. Especially the real-time flood notification dashboard is pretty useful. Cheers to that. Overall, we see the color codes in the 2 maps have a good match between the forecast and the observation. There are these blues and greens along the coast in both observation and forecast, and there is this green in the north. The rest of the regions have yellow mixed with orange color codes. But note, the color code ranges are too wide. For example, this green color code stands for moderate rainfall. And moderate rainfall means it ranges from 15.6 millimeter per day to 64.4 millimeter per day. So if the forecast is 16 millimeter per day, but it rains 64 millimeter per day, that is forecast is 16 but observed is 64, then that means a huge model error. That is, the predicted value is 4 times the observed value. But in these graphs, it will not show up as an error because both 16 and 64 will be categorized into this green color. In general, the model seems to be overestimating the rains. The total rain under this blue color region definitely looks higher in the forecast. The model predicts very heavy rainfall, that is rainfall in the range of 115.6 to 204.4 millimeter per day, right at the coast, stretching from Mangalore to Karavar. But the observation shows few pockets of this very heavy rainfall. This blue color standing for very heavy rainfall. This color is found more inland along the Sirsi, Agumbe and Sakleshpura stretch. On the next day, for the 24-hour period between 13th July 8:30 am to 14th July 8:30 am, previously we saw 24 hours before this, 12th to 13th July, now it is 13th to 14th July. The model predicts more widespread, very heavy rainfall, that is rainfall in the range of 115.6 to 204.4 millimeter per day, that is very heavy rainfall. It predicts more widespread, very heavy rainfall right along the coast, and more enhanced compared to the previous day. The observation does show enhanced rains along the coast. Some of these greens have become a little blue. Rains along the coast with respect to the previous day. So the observation shows enhanced rains along the coast with respect to the previous day. And these 3 pockets that we saw in the previous day observation, that is the Sirsi, Agumbe and Sakleshpura, the heavy rains in these pockets persist even on this day. With the middle pocket, the Agumbe region rain becoming extremely heavy and exceeding 204.4 millimeter per day. So it would be great if we can zoom and take a look, closer look at this region which had this extreme rainfall event. Perhaps this data, this rainfall data, ought to be integrated with the ISRO Bhuvan maps or the Survey of India maps, or it will be much simpler to integrate it with the Google Maps. I wonder why Google Maps do not have a weather layer. In the Google Maps, we can see the Western Ghat mountain range between Agumbe and Kollur inland. This region here, which is inland. This is the sea, this is the Arabian Sea, and this is the mountain Western Ghats, and this is quite inland. The topographic elevations can be noted better from some other high resolution dataset, like this 1 kilometer resolution data. The observed rain maxima is more inland over these mountains, and the coast is a flat area at sea level for a large distance. This coastal area is quite flat, and it's just at sea level for a large distance between the sea and these mountains. And the inland region after this mountain is a plateau. Anyways, these are the graphs and maps that I expected to see to get a decent overview of the progress of monsoon. I hope someday IMD provides a good real-time monsoon dashboard, perhaps at their official website mosam.imd.gov.in, with some historical data archive. Now let us take a brief look at what the IMD offers today. There is not a single page in the hundreds of web pages that IMD runs where they do a neat comparison between their own observations and their own forecasts. For daily observation, the best map they show is today's percentage departure from the long-term normal value of rainfall. This is more or less meaningless visually, for it does not show the heaviest or the lowest raining regions properly. For example, for Leh, with a normal of 0.1 millimeter for the July 17th rains, the map shows 100% deficiency when it doesn't rain. That is, when it is 0 millimeter per rain, that is when it is not raining in Leh, 0 millimeter, the normal is 0.1 mm, so it shows 100% deficiency. Instead, if it had rained 0.2 millimeter in Leh, then it would have shown 100% excess. This kind of statistics is meaningless. And the IMD show their predictions in a different page at a different time in a different format with no possibility of making any comparisons with the observations. The forecast made for today is removed when the observations for today are updated. That is, today's forecast was put on the site yesterday, and today they remove it and put a forecast for tomorrow, while they put the data for today's observation. So basically we can only see tomorrow's forecast and today's observational data today on their site. The maps from IMD's daily bulletins do not look very user friendly. Looking at these hundreds of numbers on the screen is difficult, and the spatial patterns are not immediately apparent. But this is how they show the rainfall data, and also the maxima and the minima temperatures data in their daily bulletins, with a series of values plotted on an outline map of India with the IMD subdivision borders. Probably we need a good image recognition software for grabbing data from this report. They have a lot of details, but not enough to track values at district level. And unfortunately, they do not have an archive of these bulletins also. Plus, the values reported in this map do not seem to match well with the daily district-wise rainfall statistics published by IMD themselves. For example, in the map, in this map, bulletin map, IMD seems to show Bangalore had 0.3 millimeter per day rains. But On the same day, from the district-wide statistics, rainfall statistic, we get that Bangalore urban had 5.4 millimeter and Bangalore rural had 11.3 millimeter per day rains on this day. Similarly, this place in Kerala looks like Kannur in the map. It shows 41 millimeter here on the map. But in the district-wise data table, Kannur shows 25.8 millimeter and so on. There are many other differences. I will in a future video show other instances where the data for the same place from the same time but from different sources show different values. So there needs to be some kind of a quality control possibly, but in general we see that different sources show different values for the observation from the same place, same time. Most importantly, they do not show the time series of observations. Especially, I wanted them in comparison with the predictions. Here is a comparison plot from the data that I scraped from imdagrimet.gov.in. This is an agrometeorology page run by IMD. And they have some reports here, archive some reports here. And the match looks bad also because the prediction is supposed to be a district averaged value, while the observation is from a point location. The point observation is what is experienced by the people at the end of the day, not the district averages. Also, probably we should get these time series plots in real time, these observations from the closest AWS, that is the automatic weather station, to the GPS location of our interest. So whenever we want to look at the weather right now, the real-time weather, we should get data from the closest AWS stations or whatever these weather stations they have closest to us. This plot shows the daily maximum temperature observed in one weather station at Pune in black. And that is compared with the 5-day forecast that IMD puts out every 3-4 days. The forecasts are plotted in red and green. We shall not go into the details of analyzing this plot here. We'll just move on. Similarly, these plots are the comparisons between observed and predicted values. The top panel shows the daily temperature minima for Pune, and the bottom panel shows the observed versus predicted rainfall comparisons. We must say this rainfall prediction in red and green looks rather bad. Again, note that these black values are the station observations and these red and green lines are the 5-day forecasts from IMD for the district as a whole. So while going through the available datasets, I stumbled upon this page where they put daily rain rate maps derived from satellites. IMD hosts it, but the data is provided by ISRO, some ISRO rapid scan group. It is always nice to watch animations of these satellite images due to its coverage over the oceans and of the surrounding countries. It gives a proper perspective of the weather system that is not possible with land-based point observations limited by national borders and oceans. So I thought, let me grab a few of these images to look. Even ISRO seems to miss updating these images once in a while. Even though the updates are quite regular, even ISRO misses, that is, there are 1-2 missing days of these satellite images this monsoon. Between July 11th and July 13th, we possibly find our rain system propagating northwards from the central Bay of Bengal, passing over the Odisha-Andhra coast and moving towards the Aravalli mountain range in Rajasthan. So this is how it looks, the image looks from ISRO satellite imagery. So this is on the 11th July. And this is on the 12th July. It looks like the rainfall has spread from the central Bay of Bengal into the land. And this is on the 13th July. This July 13th event shows huge rains in the central Indian region, shared between Maharashtra, Telangana, Chhattisgarh and Madhya Pradesh. We saw similar rain intensity in the satellite maps during cyclone Asani and in the June 17th ISRO maps in the Assam Meghalaya region. The June 15th map shown here and the June 17th map, which will be shown in the next slide, these maps, June 15th, June 17th, these maps are associated with the flooding events in the Northeast India. Unfortunately, since IMD or the state Met centers in Northeast do not maintain data archive of the previous day observations, I could not gather the ground station data for these events. But from ISRO Rapid Scan Archive, I got this image. So this is the June 15th image that we saw. And this is the image for the June 17th. This is on June 17th. We can see a large blob of intense rain around the Meghalaya plateau. We may get back to analyzing the available data from Northeast India around this time, middle of June. Around this time at a later date when it is available. In the next video, we shall closely look at the on-ground data collected from this July 13th event in central India. We will see how much does this satellite-based observation match with the ground-based station data, and also we'll look at generally at the quality of the ground-based observation datasets. Like how different data sets match the values, the observed values. So I end this video here. Thank you. In conclusion, I'll just add the best data set IMD puts out is the daily district-wise rainfall statistics. They do not put out temperature or wind or humidity data sets similarly. And also they do not maintain an archive of these reports or data sets. For public, internally they would maintain, but for public it's not available, and they do not show any comparison between their own observations and predictions. This is most important. We want to know how the observations or the predictions are matching with the observations. At the end of the day, there is no measure to know how believable are these predictions. So thank you for listening. Please share the video and if possible make a great monsoon dashboard. Thank you.